All right. Hello and welcome everybody to another video. So today we're going to start with a joke. What did the pony say when it had a sore throat? Sorry, I'm a little hoarse. Nay, nay, nay. Okay. So if I've done this correctly, today we are talking about uh, parametrization. Big word from a math teacher, am I right? So we're going to be looking at how to parametrize a function or a relation. Now, this concept just kind of means that we have these curves in the xy plane. Um, and what we can do is sometimes we can split the x kind of equation and the y equation and write them both in terms of a different variable, normally t, sometimes theta, depending on what you're working with. And it's kind of used to kind of simplify our working out a little bit. Now, let me explain how that kind of looks. So just a couple of definitions here. So if I'm kind of breaking it up into two separate equations involving t, those are what we call the parametric equations. But if we just have one equation involving x and y, we're going to call that one the Cartesian equation. Now that's the one that we're most familiar with. But now we're going to kind of see what happens. Now I'll give you an example. So let's talk about the parabola, right? The parabola, let's go x squared equals to 4y. Now, what this technically is it's just y equals a quarter x squared. And that there is definitely a parabola. Now, why am I picking x squared equals to 4y is because this is a common parabola that people like to use. So I'm just trying to get you guys familiar with it. But it is just y equals a quarter x squared. We just sometimes see it in the form x squared equals to 4y. Okay, so we've got this, and now what they're saying is you can parametrize it using these here. So that means I could write x as 2t and y equals t squared. Now note here that x is now written in terms of t and y is also written in terms of t. That means that everything can technically be written in terms of t. Okay, so if x is 2t, let's just double check, let's verify it here. Okay, x squared is going to be 2t all squared, and it should be the same as 4 times t squared. Is that the same? 4t squared equals to 4t squared. It's good. So we're all good. It does work. So that means this parametrization is on point. It works. Now, how it kind of works is if you look at your table here, we see that x equals to 2t. So that means if I was to fill out this table of values here, if t equals to -1, then x would equal to -2. And y would just equal to t squared. So what is -1 squared? Well, it's just going to be 1. Right, same thing for 0. 2t, x equals to 2t, so 2 times 0, 0, that's fine there. And if we have x is 2 lots of t, so 1 times 2 is just going to be +2. And t squared, again, is just going to be 1. So we can kind of see how the t's kind of work here, and that's just the way that we can fill out the table here using our parametrization variable. Okay. Hopefully you can kind of see that. And so what that means, and this is nice now, is because we have this, basically every point on the parabola can now be written as this, because we know that the x coordinate is the same thing as 2t, and the y coordinate should be the same thing as t squared. So it's just now we have this simpler way of kind of like determining every point on the parabola rather than talking about x's and y's and trying to use the table of values. For this particular parabola, it works that 2t would be the x value and then t squared would be the y value. Yeah. Now, let's take another example here. A circle. We've got x squared plus y squared equals to r squared. And so we've got this circle here, and we've got r cos theta, r sine theta. Let's take a look here. If we were to fill in the table here, x is r cos theta, so r cos 90. Now, cos of -90, does anyone know what that is? If you put that in your calculator, you should get 0. Okay, so you should get 0 here. But if you go for y, r sine 90, -90 is actually going to be -1. No? Yeah, it will be -1. Okay, now if it was 0, r cos 0 is just going to be, if you put cos 0 in your calculator, it's just going to give you 1. So it's just going to be r in this case. Here it's going to be 0. And this one here, if you substitute in r cos 90, again, you're going to get 0. But if you do r sin 90, you're going to get +1 this time. And that there is just a little bit of filling out the table. And that's your parametrization of the circle. Now, if I wanted to, kind of name any point on my circle, x squared plus y squared equals to r squared, it'll just be parametrized by r cos theta for the x value, r sin theta for the y value, and that would summarize the whole circle. Okay, one more, hyperbola. You guys are probably more familiar seeing it this way, but we're going to write it as xy equals to 1. And if we really wanted to, we could verify this. T times 1 on t should equal to 1. So xy, and that is correct. 1 would equal to 1. So it is verified. All good. It's a great parametrization. And so now here, if we've got t equals to -2, it's here. Well, we see here that x is just going to be t. So whatever t is, x is going to be also. But then y becomes 1 on t. So in this case, it's going to become -1 on 2. This is kind of undefined because it's 1 on 0. And then this one will become 1 on 2. And so now t, 1 on t would summarize the whole hyperbola. Yeah. Now, that's kind of how this all works and how you fill out the table, all that kind of stuff. But this is probably where it becomes slightly more helpful. Here, they've given you a parametrization. They've given you an x equals 2t, y equals t squared minus 1. Now, we don't know what the Cartesian equation is, but let's try to find that out. Now, the easiest way to do this is it's honestly, for an equation, we want y equals, right? But we don't want the t, we just want to replace it with x. So from here, I can kind of see that, well, t equals to, or let's write it this way. If I did x divided by 2, that would be the same thing as t, wouldn't it? So that would be what I'm working with. So now I just substitute t, sub t into y. And so now I'm getting y equals 2. And instead of writing t squared, I'm going to write whatever t was. So in this case, x on 2 squared minus 1. And I clean this up a little bit. This would be x squared on 4 minus 1. Now that looks a little bit more like a Cartesian equation. It's just one equation with x's and y's. That there is the equation of my graph here. Hopefully that makes a little bit of sense for parametrization. It's just a little bit of kind of swapping things out and changing things around and adding in another variable to sometimes make our life easier. And that's it. Hopefully that makes sense, and I'll catch you guys later. Okay, bye-bye.